we saw the trial and error method, which is fine. Hello, we're gonna try another method here. We saw the trial and error method, which is fine and works well in many cases. We have an alternative method here. You might like this one. Okay, we'll let's see. We're going to. Okay, here we go. Called the AC method. Now, this you would use if you had a non-unit number here, if you had something other than a 1 here in the front. So here's how we do it. We ignore the 4 for the moment, and we just write t squared minus 3t, and we put the 4 times that 20 times that 7, and we write it on the end over here. Okay, 4 times 7 is 28, so you write plus 28. Now, if we can come up with two factors whose product is 28, which add up to negative 3, then we can factor this thing. And here's how we'll do it. Okay, first of all, let's see if we can do that. How about, let's see, 7 and 4, and we'll make them both. Well, let's see, is it a minus 38? Let's see. See, minus 3t. Let's see, just hold on 1 second. Okay, I'm going to backtrack a second here. I may have copied this problem down wrong from the textbook. 4t squared minus 3t minus 7. So I fixed it and changed it to minus 7. So, all right, now, so I do the same thing. I take that 4 times the negative 7 and make that a negative 28 and drag the rest of it down without the 4. Now you need two factors. Product is negative 28, which add up to negative 3. You can see that these two would do the job, negative 7 and a positive 4. Now, what do you do with those? Well, you come back over here and you write t minus 7 and t plus 4. So that's where they go. Now, because we had altered this and made this 28 and lost the 4, here's what we have to do to fix it. We have to take that t minus 7 and put the 4 back under here. And put the 4 back under here. Okay, so that's how we make up for removing it from the beginning and putting an extra 4 on that 7. Okay, so it's kind of messy to justify that step right there, but it can be done. But we don't want to do that for these problems because it slows down the method. So, okay, so now we have this, and at this point, you reduce this fraction here to make it a 1. But since this is irreducible now, we'll take that 4 and put it back in front of the t over there. So it's a very, well, there are no steps to justify what we just did, no apparent steps, okay? No apparent steps. But this method is gaining popularity out there. And so I'm not going to deny that it's effective just because it's not showing all the mathematical steps to take you from A to B. It doesn't show that. It's just a series of steps that you make, and it works. So let's take another one over here. Okay, this one here. Okay, so again, remove the 6 and make that a minus 60. Okay, now I need two factors whose product is negative 60, which add up to negative 11. So you run through your numbers and you come up with, oops, I just get a little ahead of myself there. You come up with negative 15 and 4. Okay, so we write x minus 15 and x plus 4. That's where the two numbers come in. So this part here, there's still a little bit of guessing goes in here. You know, you're not guessing, but it's not always obvious what two numbers you should use here. But we're used to this method because this is the same method we used back in the first section. Finding two numbers whose product is equal to 60, and the middle is the sum. So, but now here's where we set those in, and here's where it takes off into something different. We put that 6 back in underneath the two constant terms like that. Reduce those if possible. This one will reduce to 5/2. And this one will reduce to 2/3. And then finally, you, since you can't reduce anymore, you move that 2 over in front of the x, move this 3 in front of this x, and there you have your solution. This is your final result. And you can check it too. Notice 2x times 3x is 6x squared. Negative 5 times 2 is negative 10. Negative 15x in the middle, and another positive 4x does make negative 11x. So it works. Is this faster than guess and check? Not necessarily. Now, there is a variation of this method. So I'm going to talk about the variation of the method. And it works like this. After you you do the same step here. You take the 6 times the negative 10, and you just think negative 15 and 4. Okay, so we do the same thing. We imagine this is a negative 60. So you imagine. We're not actually going to change it. You just think about it. What if it were? Okay, come up with these two numbers. Then you take your original expression and leave that 6 in the front there. Don't change it. But write this negative 11x now becomes negative 15x plus 4x. And leave that minus 10 out there. Then, notice we have 4 terms here. We're going to do what's called a grouping method. Okay, I didn't talk about this one from the first section because I knew I would come to it here. It's called the grouping method. There is no GCF in here, but you do have, you can write a 3x times a 2x minus 5. And over here you can write 2 times a 2x minus 5. And then you notice, hey, the 2x minus 5s agree. So you pull that out and you write 3x plus 2, and we're done. Notice it's the same answer we got over here. Didn't save that much, but there's some justification here. There's no magic going on here. The magic was this part here. We came up with those numbers and then we rewrote it. But it's all algebraically justified in here. It's just, I mean, we could have written negative 11x any way we wanted to. We just happen to write negative 15 and 4 like that, which allows this method to proceed, and then you've got your answer. So that's called the grouping method. Okay, right in here. They refer to this whole method as grouping, but this is what you'll see in that first section of the chapter, the grouping method. Usually it shows up right away. Okay, it's one of the earlier methods. Okay, so that's the AC method and the grouping method too.